Hello, everyone, and thank you for joining us for today's webinar, where we're going to take a closer look at some of the really cool and useful, efficient things you can do with Femap Data Surfaces. My name is Jonathan Hill. I'm a business development engineer here at ATA's Northern Virginia office, right outside Washington, D.C. And I'm really excited to turn things over to Frank in just a minute, my colleague, Dr. Frank Fan, in our San Diego headquarters for today's feature presentation. Before we get that far, I want to give just a quick 1-minute intro to ATA Engineering. ATA Engineering is well known for providing high-value engineering services. We have expertise in design, analysis, and test, and we're passionate about helping our customers overcome their multidisciplinary product design challenges across a wide range of industries, just some of which are shown here. Now, in addition to that, we're able to leverage our services expertise through our role as a value-added reseller for Siemens digital industry software. What that means for you is that you can turn to ATA for training, free resources, and hotline support for a wide variety of Siemens products. Now, today we're going to focus specifically on SimCenter Femap, but there's a lot of other great tools that we can also support. And that includes Nastran, SimCenter 3D and NX, Star CCM+, HEEDS, AIMSIM, and more. We have a technical support hotline that's staffed by our own engineers like Frank, and that runs from the beginning of the day on the East Coast until the end of the day on the West Coast. We also develop the official SimCenter Nastran training materials for Siemens. And once again, our instructors are going to be our engineers like Frank, who are using these tools every day. Finally, we've been recognized as a smart expert partner with validated expertise in Femap, Star CCM+, and SimCenter 3D. And then finally, before I turn things over to Frank, I want to encourage everyone to visit our website after today's webinar for a lot of really great content. That includes product information, upcoming schedules for future webinars and training classes, and free resources, which have to be my favorite part of the site. The free resources are developed by our engineers, specifically based on the feedback that we hear from users like you. So if there's an idea that you have, a resource you'd like us to consider putting together, or a future webinar topic, please feel free to reach out to me or any of us after today's call to pass along that request. I also want to spend just a second talking about the brochure screenshot that I have here. You might notice that's for Femap 2021.1, which actually released earlier this week. So that's available on the Solution Center if you want to go check that out yourself today. We're in the process of putting together our own webinar highlighting the new features in that release. That webinar will probably take place in early or mid-January. So keep an eye out for that, and I hope to see you then. But until then, I'm excited to turn things over to Frank for today's presentation. Thanks.
Okay, thanks, Jonathan. So hi, everyone. This is Frank Fan. I'm based in the San Diego office, as Jonathan has introduced. And I'm also an engineer that works with the hotline. So I think maybe some of you have talked to me before. So I appreciate those calls and look forward to getting more calls on the CAE hotline to help you with the Femap and Nastran questions. So today I will go through, give you an introduction of Femap Data Surfaces and go through 3 demo cases and to show you how we can use the data surfaces to help streamline your pre-processing need in Femap. Quick agenda for today's webinar. It will roughly be about 30-35 minutes. First, I'll just do a quick introduction to tell you what it is, what the data surface is, and the data surface editor tool, which is the way you interact with data surfaces, mainly in Femap. After that quick introduction, I will then go into the demonstration in Femap. First, I will show how to do create loads, which is the main application for data surfaces. And then those loads, you can see them as vector or arrows with magnitude, but I will show you how to turn that into an output and to visualize them as a data contour, sorry, a color contour. Another useful application for data surface is to turn the output from one model. For example, maybe you have some kind of temperature from a heat transfer model and use those temperature as the input into a thermal stress model. So I'll show you how to do that quickly as well. Throughout those demonstration cases, I will talk about some of the tips and tricks on how you can manipulate data surface and some of the nuance in working with the data surface editor. So let me first introduce and tell you about data surfaces. So basically what it is it's a table or a list. So there are values defined on coordinates. So the coordinates can be, it can be a point in 3D space, so that can be an actual point in your geometry that's defining Femap, or it can be a grid point or a node. So any of those would be fine, and those coordinates can obviously be in a coordinate system that you are working with. What data surface itself is it's a value defined on those coordinates. So basically, a better way to kind of see it is that the picture on the right shows you, the coordinates. So you can think of 1, 2, 3 column as X, Y, Z, and then there's a value defined. So this example here shows you a 1D data surface. So an example of a 1D data surface would be temperature defined over all your grid points, or all, the volume of your model. You can have 2D data surfaces or 3D data surfaces as well. Example of a 3D one would be various loads on your vector loads on your grid points. The data surfaces are useful for to help you create loads, particularly loads on surfaces and volume. So we'll see in the actual load creation dialog box, there is a method that calls out data surface, and we'll use that to help us create load in our demonstration. One extra step you can do to help visualize is to turn those loads that you've created using data surfaces into output, and then use the contour visualization method in Femap to see the data surface as a color contour. Finally, there are some additional uses for data surfaces, and those include load set combination as well as output results processing. So those are really alternative to other commands that you have available in Femap. So there are many ways to achieve something in Femap. These are 2 other things you can do with data surface that you can also achieve using other means as well. A quick introduction on the data surface editor. The data surface is a dockable tool, or it's a dockable pane. So to access it, you go into the tools menu from the top menu bar. And if it's not enabled, you can just click on the data surface editor entry, and a tab will either show up on the, by default, the top left pane of your Femap window. It may show up elsewhere if you have customized your Femap desktop, but it should not be hard to locate. And within that data surface editor, there are a set of icons that allow you to access various commands. So those allow you to have access to predefined methods to help create create data surface using various methods. We'll look at a few of them today in our demonstration. And there's actually one that allows you to transfer a data surface from one model to another. And that's how we're going to do our output to input mapping between 2 different models. 2 different models meaning 2 different files, Femap files. The actual data surface, since it's really just a table, it's listed in a tabular format, and those values can be edited directly in the data surface editor. I will show you how to do that. In addition, I think we'll see how to use Femap functions to help you populate a table quickly. Jonathan mentioned that Femap 2020.1 is out. I'm using 2020.2 for this demonstration. One of the new features introduced for 2020.2 is actually to transfer table values directly to Excel. For the example I'm going to show, they're relatively small tables. So, working in Excel is not necessary, but it's a very useful tool if you're working with data from a test, for example, or if you have lots of value to edit, it may be much faster to do things in Excel. And you can always also copy and paste the data table itself into any kind of text editor that you are using. Okay, so I think I'm going to go into the first demo now. Just a quick overview of the first demo. I'm going to demonstrate the data surface editor. I'll show you where it is, how to access it, and so on. And then I will show you the interface, the external program. It's really easy. It's just an icon. I'll show you how you can go back and forth between Excel and the data surface editor. Finally, we'll create a load, and then we'll visualize the load. So I'll show you how to do those steps as well. So they're all pretty straightforward, but I will spend a little bit more time with this first demo to get you used to the idea, and then before we move on to the second demo. Okay, so for the first demo, I'm going to work with this the wing mesh that if you have gone through some of the examples or gone through some of the default model that comes with your Femap install, it's available. So it's not a difficult model to work with, but it's good to show how we can access a lot of the features in the data surface editor. So I mentioned it's a dockable tool. So under the top menu, there's tools. If you click on that, you can see various tools available or toolboxes, and one of them is the data surface editor. So you can click that, and one of the tabs showed up, and that's the data surface editor tab. When you first open a model without any predefined data surfaces, only one icon is active. So that's where you can start by creating your data surfaces. Okay. Alternatively, if you have a toolbar for set up for the tools, you can see there is a data surface editor icon there. So you can toggle on and off your data surface editor from that toolbar as well. So with this model, what I like to demonstrate is to use the first available method. That's a long coordinate data surface. So click on that, a dialog box pops up. The next available ID for this model apparently is 103. I'm gonna just use a number that I can remember, 200. And it's always good to provide a title. So I think I'll do just something so that I can remember. There are various options and boxes available in this dialog box. So in general, in Femap, the workflow is top to bottom and left to right. So for variation option, I'm going to stick with the define multiple. What that means is basically I'm going to enter row by row this of data into my table. If you do number of points, you can specify, say, for example, 10 points, and that will give you a blank table of 10 rows. And then that allows you to cut and paste from Excel, for example, to populate your data surface table. Under data options, there's scalar and vector options. The scalar, for this case, we're looking at, I'm going to create a pressure load, so that's perfectly fine. If I want to create forces on nodes, then perhaps I turn on vector, and that allows me to enter XYZ value for each of the XYZ coordinates. Okay, so the left three columns here are the coordinate that corresponds to 3D points in the space of the model, and these are the values associated with those XYZ coordinates. I'm going to turn back to scalar. Under options, there are various options available. So the ones that are not available for a particular command, in this case, the along coordinate data surface, are grayed out. So here we can only choose the coordinate system. Rectangular, the global one is fine. And then we can choose an option of projecting the curve on surface. So since I'm going to select points on the surface, I don't need to turn on the projection option. So okay, here. Anytime you have a dialog box, you can, for XYZ location, you can go into your model and click on either points that are predefined or nodes. So the nodes in this case are green dots. It may be hard to see, but if you kind of squint a little bit, you should be able to see them at the intersection of all the elements. And there are actually some additional points as well. Those are the yellow crosshairs. So I can click on, for example, a point here or a node here, it populates it with a Femap function. I will actually talk a little bit about that. And it's telling me it's using the XYZ coordinate of node number 7. A quick pointer here is that you can do a quick click, or sorry, a keyboard shortcut. If I hit Control P, that allows me to select points. So you notice that now it's picking out some of the stuff that you actually can't quite make out. But for example, here, so Control P allows me to select points. Whereas if I hit Control N on the keyboard, that allows me to grab the nodes. Okay, so I had grabbed node number 7. I'm going to put in some value, so I'm making it up in this case. But most of the time you will have some value to put in because you know what the pressure is likely at the base of the root of your wing. So I'm going to click Add. I'm going to quickly select a few other points, putting some values. Okay, so one of the minimum number of points requirement for a long coordinate data surface is 3 points. So I created 3 points. So I'm going to hit OK. And then in the data surface editor, now a table has been created. So these XYZ coordinates, or 1, 2, 3 column here, corresponds to the nodes I had picked. I can click on any of them and then putting a different value if I desire. These don't have to match the physical or any of the nodes or points in your model, okay? Because what they will be used for in subsequent load creation process, they will be interpolated or matched to the nodes on your model to create a load. Okay, so I changed that one to 0.1. So now it's not really on this point, but slightly offset in the Z direction. Okay, but that's okay. And I'll keep it there. I mentioned you can easily work with Excel and other external programs. So on the menu bar of this data surface editor, you see that various icons have become active. Some of them are still not active, but one of them has a little X in the foreground, and that allows you to send the data surface to Excel. So if you have Excel and you're working with Femap, you can click on this icon. The messages window down here tells you what it's doing. In fact, it opened up this tab in Excel or this workbook in Excel for me, and you can compare the data. It's actually almost the exact same formatting as the data in the data surface editor itself. If you can see that. So that's just with this click of a single button allows me to go to Excel. Here, if I have some formula or some data, I can go ahead and update this table, for example, and then I can actually go ahead and do a Control-C on the values I want to use in the data surface editor. Go to the appropriate column and do a paste. So that updated the values, okay? So that's handy if you have data or test data available in Excel, you can then bring it back into the data surface editor. If you are not working with Excel, you can do this copy text to clipboard. You can use that icon to populate your clipboard with the same text data. And I think it's tab delimited. So I click on that. So if I go back to Excel, I do a Control-V, it gives me the same text data as well. Because the text is tab delimited, it puts it into different cells in Excel automatically. Okay. If you manually edit the data surface table, what you need to do is you need to actually save it for the value to take hold, for it to be effective. So now we have this data table created. One way to see it is to go into your model info tab, and under model, there is a branch for data surfaces. So I had worked with this model earlier, but now we can see that there is this one we just created. So that's ID 200 pressure profile. if you right click to bring up the context sensitive menu, you can do, you can either delete it, you can remember it, and you can also load it or edit. So it says reload, but basically it loads up into your data surface editor, and you can see the value that were saved. You know, I had changed this one to 0.1 and that one to 120. So, so that's how you can go from data surface editor to how it relates to your model in terms of where it's stored. So once that's done, the most useful part of data surface for most of my work is to create loads. So I'm going to go ahead and create a new load set. I'll make it the same ID just so I can kind of remember, and I'll give it an appropriate name. And under on-load definitions, if I right-click, again, context sensitive menu pops up. I like to do elemental on face because I want to apply a pressure on the top face of this wing, or the positive Y face of the wing. So I'll click on that. The face selection dialog shows up. The adjacent faces is a great tool. So what I can do is click on any of the face on the top surface, and then highlight it. So with a tolerance of 20 degrees and within the face that I selected, it picked all the adjacent or all the elements with the faces that are basically adjacent to it within a tolerance of 20 degrees. Okay, so if it doesn't quite work and you have, you know, perhaps more camber or whatever, you can adjust the tolerance to for it to basically grab all the surfaces, all the faces at once. So in this case, it worked well because the edges, it's basically 90 degrees, so that's much greater than 20 degrees. So I'm going to click OK. Remember, all these faces have been picked. I'm going to create a pressure load, so that's the type. Direction, normal, that's fine. The method, this is the key thing. We want to use the data surface method, okay? And then under load, the value, even though we are going to use data surface, this is a multiplier. So if we have the exact or the actual magnitude in our data surface, we can just go ahead and use 1.0 and then select the appropriate data surface here to create our load. So I'm going to use the pressure profile, and then I'll click OK. So, you know, down here in the messages window, it tells me 36 loads have been created, and the top surface is basically 4 elements by 9, so there are 36 elements. So that kind of confirms there's a load created for each of the element faces. So you can toggle on, again, from the toolbar, the loads. There are various ways to do this. This is probably the quickest way. And I think I may have set it up so that it displays the vector and the magnitude. So I had, you know, if you don't remember exactly, we can go back to the surface editor. So this, basically at this point, I specified a value of 120, but it's interpolating. So the midpoint of the, or the centroid of the face gets 115 load, basically all along this X value. And then down up to about 40 here. So that, I think I specify a value of 40 in one of these nodes. Okay, so it's interpolated. So now you define a pressure loading over the surface really quickly. So you can see that the value, you know, if you have data from either another model or test data, you can do this load creation quickly over large surfaces or volume. Okay. So the next thing I like to do is sometimes, you know, if you have a really large model, you know, this simple model, you can see the vector and the value pretty well. It becomes overwhelming if you have very fine mesh and you can't really make out these text very well. So what's useful is we can create a contour based on the value of the pressure that's applied and then view that. And that'll be a much cleaner looking chart if you have a very high density mesh. So to do that, what we will do is use the model output from load command. And then the load that we want to convert is a elemental type of load, and it's a pressure. So I'm going to click on that. I will click OK. And again, the messages window tells me that it has created an output vector, and it moved it over to 24000004. So now I'm going to go into post-processing, or alternatively, you can turn on the contour plot from the toolbar. So I like to go to post-processing. Under contour, I'm going to select contour. There's only one output set that I have set up, and I'm going to select 24000004 to match the one here. And that's the contour plot of the pressure loading that's applied to the top surface. So you can toggle off the vector representation of the load, and now you can present the pressure loading as a color contour. You know, the legend here, I have some of the text and view legend turned off, so we can turn those back on. Okay, so and you can rename these if you want, right? Okay, so I think that's what I like to show to start off with. You know, this is the first demo, second demo, and third we'll go through a little bit quicker. And then one other thing, additional tool I will introduce is Femap functions. If you have any question with this demo, I think you can either hold on to it or send a message to Jonathan, and we'll get to it. Okay. So the next demo I'm going to do, I'm going to go back to PowerPoint real quick and just kind of give you an overview to set it up. The second demo, I'm going to look at a ring shape model. It's going to be 3D brick elements. We'll do the data surface creation directly from the load command. Instead of creating a data surface first, you can actually just go ahead and create a load, and if you need a data surface, go ahead and create it right there and then. I will show you a Femap function and what that is. There's various things called function in Femap, so this is a different one than the XY function. I will then show you the mesh data surface method within the data surface editor. That's where we will use the Femap function. And then we will do some updating of the data surface and load, and I'll reinforce one of the things, basically a caveat in using data surfaces. Okay. So this is the mesh that I came up with for the second demo. Again, these are admittedly simple mesh, but the flow or the workflow is what's important, and that's what I want to demonstrate. So because I had already turned on the data surface editor, it's on by default in this model. So what I can do is I can actually close it because I'm going to create a new load set. I'm going to first create again, I'll create a load set 200, and then this will be temperature. And right click on load definition to bring up the context sensitive menu. I'm going to do nodal load this time. So for each node on this model, I would like to have a temperature. I'm going to do select all because I want each one of them to have a temperature. And this should be a relatively familiar looking dialog box on load creation. The type is going to be temperature. That's what I want to do. I'm going to do data surface again, multiplier value. I'll use 1.0. And then instead of selecting using the dropdown, there's this table-looking icon. If I click on that, it pops up various methods to help me create data surfaces. In this one, I'm going to create a mesh data surface. So that's going to create a data surface on the mesh. So the XYZ points are based on the nodes that are existing in the mesh. So it brings up a dialog box. This is exactly the same dialog box if you are working in the data surface editor and click the mesh data surface method. Okay, so ID, I think I'll just go ahead and use 200 again. And a title, quickly define temperature over nodes. The variation type So I'm going to do node, so that's why it's on node ID. You can alternatively do element ID, which is also fine for temperature loads. There's not a lot to choose from in terms of option, I think, for this point. Actually, there is. So I like to use the cylindrical coordinate system for this case, and I'll explain why in a second. So I'm going to pick the global cylindrical coordinate system. Okay. You can see a little dot here in the middle of the ring. That's the origin. You can turn that on and off by the options, but I have it on. So by default, there is the Cartesian coordinate system, there's a cylindrical coordinate system, and then the spherical coordinate system, all using the same origin in Femap. You don't have to create those, but you can use them to help you define your load or model or whatever. So in this case, the workflow, we selected node, we chose the right coordinate system, which is the global cylindrical. And then under here, you can either put in a value, so that would be basically a constant value for all your nodes, or you can put in an equation. So the equation is really asking you to use the functions available in Femap, and then to basically loop that over to all the nodes. So let's say we have some kind of gradient over through the thickness or the radius direction of this model, and that's the reason I use the cylindrical coordinate system. And let's say the gradient is, say, 300 degrees over 10 inches. And that's going to vary over the, so in cylindrical coordinate system, you have r, theta, and z. So that's going to vary over the radius direction. So in terms of the function, I will use x and d. So that's the first coordinate in terms of the order triplet that defines your the coordinate of each point. And by default, we'll use exclamation mark to denote a variable, and the I is used as the default for whatever variation you have picked. So the exclamation mark I will loop over all the node IDs in the model that were selected. So to select those IDs, I will do select entity, and again, select all, because I want all the nodes to be used. Okay, once that's done, I will click OK. And in the messages window, it tells me 1,488 nodes selected, and 200 data surface 200 has been created. It pops up this again because it allows you to click OK here to finish the load creation process. So now it's telling me 1,488 loads have been created. And if I look at the information on my model, there are 1,488 nodes. So that implies there's a load created at each node. Okay. Again, we can toggle on the load. So this is not even a very fine mesh, but you can see that it's a little bit difficult to perhaps see if you want to see a large, your overall model. But in terms of if we zoom in, you can see that it gives us 300 degrees at the outer edge. What I didn't mention is the dimension of this ring, which is 10 inches in diameter. So I have set up so that it's 300 on the outer edge, and then it will basically linearly decrease as a function of the radius. Okay. Again, it's really painless to make that into a contour, so I'll just do that real quickly. Model, output, from load. So this is nodal, and then this is temperature load that we created. Okay, again, 2400003. So go to post-processing, request contour, and then and then toggle over to the right output set vector, output vector in the right set. So this is what the your color contour of the temperature looks like. Okay, so this can be a load that you apply and then to get thermal stress. And we did not use the data surface editor at all in this case, so we can turn it back on. So I used the toolbar to do that, and then we can go ahead and instead of creating one, we can do reload/edit. And I want to just take a quick look at the one we just created. So notice instead of using column 1, 2, 3 to represent each point, it just used a node ID for each of those in this table. And then for each node, there's a corresponding point. So a node has XYZ or arc theta Z defined for it. So it is a coordinate in 3D space. And then if I click on any of these cells, I can see there's a formula that I had typed in. So we can, so you can edit these formulas and then apply and then use context sensitive to fill down. So you can go ahead and basically change all these formulas if you want to. So I'm going to show that real quick. I'm going to just make it so that it's 400 degrees over the 10-inch. Okay, so I type in that formula, and then I want to populate the whole entire table. So I selected the first cell. I'm going to do Shift key and then click the bottom one, and then right click and do fill down. So now I updated all these to the same formula that I had put in for the first cell. Okay, so you probably noticed that the data surface changed, but the color contour did not change. And actually the load itself also remained the same. So the one thing to remember is that the data surface is decoupled. It's used to create a load, but it's not linked to it. Okay, so it grabs a value when you create a load and that's it. It doesn't update it. So let's go ahead and save this since we made some changes to it. And to create, you need to create a new load set in order to have the data surface reflected in the load itself. So I can go ahead and do a new load set and then quickly define. I'm going to just do it real quickly to show you how you get the updated values. Okay, so the numerical value updated, that's actually plotting the actual load. Again, the contour is an output. That also is not associated with the load itself. It's a visual representation of the load when you created it, when you created that output. So if you want to have another color contour of the updated load, you will have to go through that step again as well. So that would be, if you remember, model output from load, and then that will give you the output the output vector, and then that allows you to visualize that as well. Okay, so that's the second demo. I'm going to go through a third demo a little bit quicker and go back to the PowerPoint. So I think I cover all these points. One thing I like to point out is that Femap functions, you saw me use the xnd command. These are basically the function allows you to input numerical value or a function instead of numerical value. So instead of grabbing the actual XYZ of a point, you can just go ahead and call xnd, and if you know the node ID, you can put that number in there. And this is equivalent to specifying the, if xnd is at 1.2, it's equivalent to putting 1.2 in that box. Okay, there are also other math functions available. So it's natural log, exponent, as well as sine, cosine, and so on. There are also model query functions. So if you have some, so this is a different type of function. This is a Femap xy function. If you have that defined, you can interpolate the function at x using this command, fni. Okay, and xnd, ynd, and znd we talked about already. So one thing is to look at Appendix C in the Femap user guide, and that's very useful to give you a lot of, basically it goes over all the functions. The third demo I'm going to do will take a solid rod, or an output data from a solid model, and then grab the surface value of that and then put it into this 2D pipe model. Okay, So we'll look at various commands again within the data surface editor. In particular, we'll look at a copy and paste command. And then there's some tools that allow you to line up the data contour with the destination model. Okay, so let's go to the, so in this model, in this demonstration, the first model is, like I said, a solid, and it's got some output defined over it. In this case, I didn't have anything set up really, but I did create a this output, and we'll use that output as, for example, say the temperature over volume, and you want to map that onto the surface of a pipe. It could be pressure in other cases. So there are various cases where you do want to go from one model to another model. The other model looks like this. It's a finer mesh, and I mentioned it's an open pipe, so the geometries are different. Another thing that's different is the coordinate system is actually not the same. You notice along the long direction, that's positive z. In the pipe model, it's x. Okay, so in the model with the output, what we will do is to go to Data Surface Editor, and then look at the output map data surface command, turn and click on that. And I think I'm going to stick with 200 here. I'm going to skip the title, a little bit short on time. There's only one output set, so that's fine. It was named temperature map. There's only one vector, so that's basically what's on the display right now. I'm going to click those options and go click OK. Okay, so after a second or so, it tells me some information in the messages. And more importantly, in the Data Surface Editor window, ID 200 has been created, and various icons have been activated as well. So the one we will actually be using is this copy data surface to clipboard command, okay? So if I click on that, it tells me it's been copied, and then I can go to my second model where I want to create the input and click on paste. Okay, so basically it brought over the same table from one model to another model. Okay, in this model, there's this icon that says operate on data surfaces. So with the drop down, you can plot the output. So because we know the coordinate systems are different, so that's what's showing us. Okay, that's how they're related. So I want to take the z-axis and basically put it into the x-axis. So to do that, I can do it directly in the data surface editor, and I can use this align output map command. Okay, so this is a standard vector dialog box. I can use the rectangular global coordinate system, that's fine. So I want to go from z to x. So the from axis will be z, and the origin was here. I had looked at it before, so that's okay. And then I want to make it and go into x-axis. You can always preview it, make sure. Okay, so it took that data surface and basically rotated it into the x-axis. So now that looks right, and I can turn off the plot command and turn back the solid of the current model. So once the data surface exists in this model, and rotate it into place, we can basically go through the same steps and create our load. So I'll go through a different workflow this one. So I'll go ahead and create a new load set. Let's do it quickly. Done. So that's active. And then model load. Let's see. I'd like to do I'll make temperature this time. So nodal. I'm going to select all the elements. Temperature is a type. Multiplier 1.0. Data surface, and okay, it was 5. Sorry. Nodal, select all. Okay. Temperature, multiplier 1.0. data surface and data surface 5. Okay, created those loads. So we don't need to create another set. Sorry about that. Okay, we can toggle on the load. So this is what I was talking about. It's relatively fine mesh compared to the original one. So in this case, it interpolated and putting value. So it's hard to see. So that's why we do the contour. So I'm going to create a contour and we can look at the results. So model output from load. This time is nodal temperature again. Okay, and the vector has been created. Contour. All right, so that's the end result of the contour that's been created. 100 degrees or so at this end and 1 degree at that end, and some kind of variation throughout. And it's pretty consistent with what we have here, even though the nodes it's much further apart in this model. In this case, you can see the interpolation working. Of course, yeah. So I have I don't have the continuous color turned on. So if you want continuous color for better representation, you can turn that on in the contour plot option command. So that's the final demo I have. This one takes you, allows you to basically go from the output of one model and then create it as the input for the other model. One thing I like to just point out real quickly, if I were in Data Surface Editor, if that's the active window, if you hit F1, it brings you up not just the help menu, but the help in the actual right context. So Femap, F1 is pretty helpful. A lot of times if you get stuck on a command, not sure what to do, the F1 key or the function 1 key allows you to do that. I mentioned Appendix C for the to get help on the function. So under user guide, if you extend that, there's function here in Appendix C. I like to make the fonts a little bit bigger. So to do that, you can hit the Control+ key. Okay, so and then you can read this, if you ever come across various things like the FNI function I talked about that allows you to interpolate. Okay, so again, various things that are useful in Femap, F1 is one of them. So I think that wraps up my the 3 demonstrations that I have prepared. And I think if we have any questions, I will stay online and answer those.
Yeah, perfect. Frank, thank you so much. Lots of great little tips sprinkled in there. I love the F1 context sensitive help, Femap functions, switching between node and point select. So lots of great stuff. And then especially that last demo, I know I've used data surfaces frequently myself to copy thermal loads from a thermal model over to my structural model. So really great stuff. Anyway, I've updated the meeting settings, so you should be able to unmute yourself now if you'd like to ask questions out loud. You can also submit questions in the chat, and we can go through those as well. I think one kind of first question that I had for you, Frank, was just very briefly, what are some other use cases of data surfaces, other times they might be useful?
Yeah, so I think that's a really good question. I really just talked about load creation. There is, output to input mapping, but if you look under the Data Surface Editor window itself, under the first icon, there's actually load set combination and result set processing. And there's one that's grayed out. It's the connection manager data surface command. So those 3 are additional to creating loads. And what they allow you to do is really, there's redundancy in Femap. So you have different paths to achieve what you want to do. The load set combination, you can create, if you have various G loading in the XYZ direction, positive, minus direction, you can quickly create combination of those by putting in linear combination of the various loads you want to create load set with. the result set processing is an alternative way to basically RSS or envelope your results. So there's multiple paths to accomplish the same thing in Femap. The connection manager is grayed out here. I don't have any connection like glues and that kind of stuff in this model, but that allows you to activate or set up various various connections. So that's another useful feature of this. So because all those are kind of table related, that's why it's probably grouped here. But you can't work with them in Data Surfaces editor. So thanks for that question.
Frank, could you repeat what you said about connections? I'm not quite sure I understood how these data surfaces will interact with models that have connections.
Yeah, so they actually don't interact with it. So under model info, there's this connections branch. So if you have regions and connector set up and there's property, what the data surface editor, the connection manager does is allow you to manage those entities. Basically how the property is associated with the connector and what regions are defined. Does that make sense? It doesn't actually work with the output data or the loads. It just works with these entities.
Yeah, so in the data surface editor, I think you'd have essentially a table where each row was an individual connection. So you could see the property that connection used, the regions, things like that. And so if you had to, do bulk update properties for a bunch of different connectors at once, things like that.
That's exactly right. Yeah. So basically, it's a table that allows you to set up what is the source and what is the target surfaces and what properties associated with it. And there's drop down, that allow you to choose a different option if they're glued or the type of surface or property that you've created for that glue and so on. Again, this is the context-sensitive help. There's a section on connection manager if you like to, since I didn't do a demo, it might be good to just kind of scan through this and get an idea if you're interested in using it. A lot of time working with connections, it's hard to keep track of, what connections using what region and what properties associated with those. So this is one way to help you organize your connections.
Cool. Great question. Brian, does that clear up, I guess?
Yeah. No, I understand now. Thanks.
Okay, cool. Are there any other questions out there? You can either unmute and ask or put them through the chat. Brian and I were sort of chatting on the side throughout the presentation and discussing. I think we're probably all aware that Femap just has like a million ways to accomplish any single individual task. And so I think a lot of what Frank showed today, there are other ways that you could do that, whether you do it externally in Excel or an external script or anything, but that there's also just benefit to be able to do it natively within Femap, load combinations and things like that you could do through the data surface. So a lot of different kind of unique things that it just helps automate, make it a little easier.
Is the data surface editor exposed through the API?
The data surface object is, yes.
Yeah, okay. All right, good.
Yeah, I'm not sure about the editor itself, but the data surface are. Yeah, the data surfaces that you created, or you can create data surfaces with API as well.
Oh, we got a question in the chat that I missed. I apologize. Asking if you could do boundary conditions with this tool.
Let me just take a second to think about that. So I don't think you can work directly with boundary conditions. I don't think you can work with SPC or SPCD card in that sense. What I think you could do is if you have displacement, you can map it over, but I think you still need to work with SPC separately. But you might be able to streamline it so that you have a group created off of the loads that you are creating, and then to help you with the the displacement on those SPC cards, but not directly on boundary condition as far as I'm aware of.
Cool, thanks, Frank.
Mm-hmm.
Unless there are any other questions, you can certainly ask now. You can also follow up with Frank or myself or anyone else on the call today. Short of that though, like I mentioned, we recorded today's presentation, so it'll be up on the website probably tomorrow, maybe on Monday. So keep an eye out for that and feel free to forward that along. And otherwise, I hope everyone has a great afternoon. Thank you so much.
Yeah, thanks everybody.